Hello from Lindau, Germany. I'm Brian Malow, and we're in front of the Inselhalle, the conference center that is hosting the 74th annual Lindau Nobel Laureate Meeting. This year is a chemistry meeting, and we have about 30 Nobel laureates and more than 600 young scientists from more than 80 countries. And I'm speaking to an American scientist from, I used to live in the Bay Area, so Vidia Gokool is a forensic chemist. And you said you're from Miami?
Yeah, originally.
Originally from Miami, but she's working at Lawrence Livermore Laboratory, National Lab in the Bay Area. And thanks for talking to me. Forensic chemist, that's great. So, so this is like applied science, not pure, what was your path into this?
Yeah. So I'd say back in, high school, at that point, good at science, good at math. I thought maybe I wanted to do something in that space. My high school chemistry teacher was very encouraging. Gave me all these weird side projects when I finished my work to work on. So there's always an interest there. And I think forensics really sparked up once I took my intro to forensic science class in undergrad. Started to see more of this application space. I went to a wonderful university, and
Where did you go as an undergrad?
I went to Florida International University. So I did my undergraduate and my graduate schooling there. They have a wonderful forensics program. And my professor at the time was actually a DEA agent. So she was explaining things that they're actively using in the laboratory, and she's able to put the textbook learning into action and show what that looks like. And I got to work in labs. The laboratories I worked in as an undergraduate, real casework would come in from time to time. And going into graduate school, the experiences just continued.
Excellent. So, let me take you back a little farther first, too. It's like, did you always know you wanted to be a scientist? Was there any kind of inspiration for it? Or did you have any possible other career path?
Yeah, I'm not sure when I decided I wanted to be a scientist. I think there's a bit of overlap here. I think every kid kind of goes through a phase where they want to be a doctor. And I feel like chemists, we go through that phase and then we realize I don't want to be in charge of someone's life. And that kind of steers us out of the gushy sciences and into the less gushy ones.
I've often thought about that, as a comedian, if I mess up, I just get my ego bruised a little bit, but compared to an airline pilot, that's a lot of responsibility. Yeah. So and then forensics, was there a particular inspiration?
I get that question a lot, and I think my inspiration was Abby Shudo on NCIS. We were an NCIS family, so every week it was on. And watching everything Abby did in the lab, I mean, obviously, it's not a one-to-one. It's not really going to be like that, but it's still really amazing to see the role that physical evidence plays in a case.
Interesting. And, let me ask you about media portrayals of science. And this is probably a great one because there are a lot of forensics in movies and television. Do you ever get frustrated with misconceptions or myths that you see in TV or film?
I think the biggest misconception or sore point is when people, especially if, God forbid, they are on the active end of being in a case, being frustrated with how long it takes things to happen. On TV, it's Abby. Abby has a lab, and she runs fingerprints, and she does the DNA analysis, and then she'll look at the firearms and say, oh, shot out this gun. Those are all different departments, different trainings, 2-3 years of training individually beyond getting your degree to do each of those jobs. So I think that's where some of the frustration comes in from the layman, is not understanding, you have to do them one by one. It's one piece of evidence that's moving through this process. So it takes a while to just run the test, let alone interpret it and come to some decision about what that evidence means.
I was going to ask you if your family, do they understand your science? But the fact that you said that you were a family that already enjoyed these forensic shows. So were they kind of, was that exciting to your family that you're going into that field?
So, I mean, I think this happens to everyone once they get into their advanced degree. I don't think my family really knows what I do. So they know I'm a forensic scientist. I've moved around a lot within the forensic sciences. So I did do some fingerprint work. I worked with scent detection dogs for a long time. I analyzed human scent. Now I'm more on like chemical detection work. So I think at one point, my dad was caught on the telephone saying I was a dog trainer because he understood that I was working with drug dogs and bomb dogs, but he didn't quite put together the chemistry aspect.
Right. Well, so you said a few things there that, like,
Yeah.
when you were doing fingerprint work, like, so tell me about your
Yeah.
work, what it was or has been, and what it
Yeah.
is. Like, what do you mean fingerprint work? Like, what did that
Yeah.
entail for you?
So that work was done, I think I was an undergraduate, it's probably around 2017. I was an intern at the Defense Forensic Science Center. It's in Forest Park, Georgia, so a little bit outside Atlanta. And in that internship, I returned 2 summers. So the second summer, we looked at an array of processing methods that you use to pull fingerprints off of tape. So if you think about tape, there's a sticky side and there's a smooth side. There's a lot of processing methods that you can use for that smooth side because at the end of the day, that's really similar to like a piece of smooth, like metal or plastic. You know, it's a non-porous material. That sticky side is more challenging. And especially when you think about tape, tape gets stuck to itself. So you have to be able to pull it apart, lay it flat, and you can pull a fingerprint off of that. There's a ton of different methods. There's also a ton of different types of tape. There's masking tape and scotch tape and everything. So we went through an array of methods and tried to figure out what's the best approach because at the end of the day, you have one shot of developing it properly and getting the best print you can off that piece of evidence.
Yeah.
So we ended up putting together a publication of an array of tapes, an array of processing methods, and looking at what's the best combination, what's your best bet of pulling off a good print. And while it's not a field I work in anymore, I actually think that's probably the most impactful piece of work I've done because I know it's been incorporated into the last set of like Interpol recommendations for processing fingerprints. So it is something that I know has made an impact in the field and how people approach things.
That's excellent. And then, since you're apparently not a dog trainer, well, how do you explain to your dad what you did? What was your connection with the dogs?
Yeah,
You weren't their trainer.
In graduate school, so I went to Florida International University. My graduate PI was Dr. Kenneth Furton. He's really pioneered this area of research around scent detection and especially human odor work. But there's sort of an institution at Florida International University now. It's the Global Forensics Justice Center, and they work with a lot of dog groups. So the group I mostly worked with was like Florida Highway Patrol, and we help do certifications of their canines, and we also do concurrent research. So you think about bulk drugs. The dog is finding cocaine, they're finding heroin. There's an odorant associated with that material. So the research component comes into identifying what that odorant is. Can we make a mimic? Especially if you're thinking more on the explosive side, you don't want to have to be carrying around a live explosive all the time to train your dog. So can we mimic that odor in a reproducible way? And now you have a safer material to work with and still train your canine. And at the end of the day, we did help with recertification. So someone that's outside of the process, we aren't as necessarily staked in whether or not the dog passes or fails, but as a third party, can we observe the canine can find the target and the handler isn't correctly interpreting that they found the target odor.
Okay, interesting. And then was there also did you say the third thing was about human scent?
Yes, yeah, so that's actually what my graduate research was, and that's what my dissertation topic was on. So there's a long history of canines being used to track individuals, goes back hundreds of years, but we don't have an accompanying instrumental technique. So there's, like I said, there's drug dogs, there's bomb dogs. If you find a seizure of drugs or you find a bomb, you take that back to the lab, you run it on usually a GCMS, and you're able to—
what?
A gas chromatogram, mass spectrometer, sorry.
Thank you.
So you are confirming the identity of that compound. So you can say, this is RDX, this is C4, this is cocaine, this is heroin, and you can look at that molecule on your instrument and confirm it. But we can't do that with human scent. So what we do is we get another dog to confirm what the first dog said. And these dogs are really well trained.
You get a second opinion from another dog.
Yeah, these dogs are really well trained, but we don't. It goes farther, and especially in explaining this to the general public, if we can come up with an instrumental approach. So I developed an approach to use the same instrumentation that we use to confirm Bob and drug seizures to look at human scent. So it's the first publication on that topic, using an instrumental approach to individualize someone's odor using instrumentation.
Interesting. And is that's all stuff you previously worked on, and then what's your focus nowadays?
So I've moved into different chemical targets. You know, there's a lot going on in forensic science.
Yeah.
There's a lot of overlapping approaches and techniques. So I'm using a lot of the same techniques now, looking at different targets. One of my big projects right now is I'm looking at illegal pesticides that are being used in the cannabis industry in California. So these compounds are not legal to have in the United States. They're not legal to be used in any agricultural setting. And they're being used in dangerous ways, and they're being used on products that may be getting into the public supply.
Okay. And it would be dangerous for someone to use that marijuana that's been treated with those pesticides?
Yes.
Yeah.
So we don't know to what extent, but we know that the whole reason that these compounds are banned is because we know that they're toxic. Okay. So the government, the EPA has said, no, you can't use them, but we're finding these products in mainly illegal grow sites in the state of California. So, you know, set up shops growing large amounts of cannabis.
So I like this, that this very applied science. I mean, I love pure research, but sometimes if I'm talking to a chemist here, it can be very complex and hard to wrap your mind around the pure research aspects. And so this is like, even like to young scientists that might pursue a career in chemistry. And also, let's talk about the meeting a little. So, but just in general, in your career or the meeting, to young scientists who might be interested in this, anything to say to them about this career path that you've had?
Yeah, I would say follow things that interest you. If you have a driving mission, I think that's the biggest. I think my driving mission has always been to leave the world a little bit of a better place, and I think that's where my work falls into it, is trying to make a positive impact in the world through my science. And maybe that impact looks different across the different areas of science, but I think as long as you have that goal and that mission, that's what drives you, and it makes it easier to show up even when things are hard or problems are difficult or your instruments are broken and you're behind schedule, just knowing that you're still working towards this thing that's larger than yourself.
Excellent. That would be a beautiful end note, but I just wonder about the meeting itself here. I know it's only the first full day. Yesterday was the opening ceremony, and today's the first full day of programming, but any highlights or anything you're looking forward to in the coming week?
Yeah, I mean, it's a very unique setting. I'd say that I think the thing I'm really looking forward to is tomorrow I do have my Nobel Laureate lunch. I'm very excited to get to sit down and this small group setting, have a conversation with Joaquin Frank and sort of pick his brain, and not that I don't love the other attendants, but not get swarmed by other people competing for attention.
I mean, there are only 30 of them and 600 of you. Yeah.
So I think that's the thing that's most on my mind right now.
Excellent. Well, thanks for taking the time. I'm sure I could ask you many more questions, but thanks for taking the time to talk to me. And we'll be back with more interviews with these extraordinary young scientists. Thank you.